What is federated learning? Federated learning is a way to train machine learning models without moving the data. Each participant, like a device or organization, trains a shared model locally, then sends updates to a central server. The central server never sees raw data. It only sees the model updates. It uses those updates to improve a global model and sends that back out to start the next round. So how does this actually work? First, the server creates an initial model and sends it to all the clients. Each client trains the model locally on its own data. The data never leaves the device. Only updated model parameters are shared. Then comes secure aggregation. Clients encrypt their updates and send them to the server. The server combines these without knowing what each one contains. The server updates the global model and the cycle continues. There are two main types of federated learning. Cross-device federated learning trains on millions of small devices, like phones, when they're idle. Cross-siloed federated learning uses larger participants, like banks or hospitals, each training on behalf of an entire organization. There are also three key variants. Horizontal federated learning combines participants with the same types of data, like hospitals training on patient records. Vertical federated learning connects participants with different types of data about the same users, like a bank and retailer collaborating. Federated transfer learning is for cases with little data or feature overlap. Why is federated learning considered privacy-preserving? Because the raw data never moves. Only encrypted model updates are shared. Privacy is protected by layers of technology, like secure multi-party computation, homomorphic encryption, and differential privacy. Federated learning has its challenges too. First, not everyone's data looks the same. That makes it hard to create one model that works for everyone. Devices also vary. Some are powerful, some aren't. That affects training speed and consistency. Communication is another issue. Sending updates back and forth takes bandwidth. And finally, shared model updates can still be attacked. Malicious clients can try to manipulate or reverse engineer the model. Despite these, federated learning is being used in real-world systems today. In healthcare, it's helping hospitals train on sensitive data without sharing it. In finance, it helps banks detect fraud across institutions without exposing customer data. On smart devices, it powers things like keyboard suggestions or voice recognition without uploading your personal data. And in IoT and edge systems, it supports real-time decision-making while preserving bandwidth and privacy. Federated learning is also evolving. It's becoming more secure, scalable, and auditable. In short, federated learning changes how we train AI. It moves the model, not the data. And that shift is shaping the future of privacy-preserving AI.